Hi, I'm Alan Bresnick, Cable Video Practice Leader for Light Reading. I'm here in New Orleans at SCTE Cable Tech Expo. We're at Huawei Technologies. I'm talking to Allen Wang, who is Principal Solutions Architect for Huawei. Hi, Alan.
Hi, Alan.
So, Alan, what are the challenges for cable operators when deploying DOCSIS 3.1?
Well, for 3.1, I think in order to match the fiber to the home service tiers, right. We're talking about gigabit or higher, you really requires plan upgrades. So for plan upgrade, we're mostly talking about moving the upstream spectrum limit to 1 gigahertz, 1.2 gig, or 1.7 gig. Right, so there are steps defining the DOCSIS 3.1 specifications for these upstream upgrades and downstream frequency upgrade, both in downstream as well as the upstream direction.
Given all that, what do you see as the best solution for DOCSIS 3.1?
Well, for other than plan upgrade challenges, there's also performance issues that we had to address. So, for example, with the existing solution in the head end, you're really looking at the best possible performance will be 1K QAM from the head end. It's about 6 dB away from the SNR perspective to hit the 4K QAM performance target.
Right.
And
so we're talking about noise levels here, right?
That's right. It's for the SNR. And in order to hit the 4K QAM modulation order, you pretty much had to get rid of the analog optics that's used today between the head end and the fiber node.
Right.
And one way of doing that is to go with the distributed access architecture.
Right.
And Huawei's DCCAT is one of those architectures, one of the solutions that fits in with that architecture. Mm-hmm. And in our solution, we actually use a 10 gig asymmetric GPON interface. It's basically 10 gigabit down and 2 gigabit up, 2.5 gig up, shared between 4 CMCs, coax media converters. These are strand-mount devices that replaces the existing fiber node. It supports all the legacy QAM services, and it gives you the 3.1 capacity. And with the 1 gig plan, you're looking at about 6 gig down and about 600 meg up.
That's pretty good.
To a very small group of users.
Right.
And every MSO is thinking about implementing a fiber deep architecture with DCCAT, which is a PON connected CMC devices. The node split becomes a much simpler operations, because you can flexibly adjust bandwidth that's needed for each one of the CMC devices. With pre-provisioning, CMC are basically plug and play in the HFC network. So it's really no more difficult than hooking up a fiber to the home user with the ONT.
I understand how the analog transport is the weak link right now, and replacing with digital fiber will make a big difference.
That's right.
But won't RemotePHY also do that? Right.
So there's obviously been a lot of discussion between the choice between RemotePHY and RemotePHY.
Right.
RemotePHY is the Huawei's DCCAT solution with the CMC.
RemotePHY is the same thing as distributed CCAT. Right?
That's correct.
Okay.
And we are a strong believer in the RemotePHY being the right choice.
Because?
There are several reasons, right? So with the RemotePHY, you're actually solving the space, power, and heat issue in the head end once and for all, right? So by some estimate, if you stay with the head end based CCAP solution, as you push toward more fiber deep migration, you will eventually run out of rooms, run out of space in the head end.
Right.
So CCAP in itself was a great concept in highly compact CMTS solution that covers all legacy QAM and video and voice services. But as we see this downstream bandwidth demand continue to grow at 50% CAGR, it's really not a long-term solution to fully resolve the head-end issues.
Right. So even with RemotePHY, we'll still end up with the same problem in the end.
That's correct. If not today, but a couple of years from now.
Right.
And you'll be running out of you're facing with the exact same set of issue in the head end again.
You're just kicking the can down the road.
That's correct.
Okay.
Yeah. So with DCCAT Remote Magpie, you basically place all the active components out into the field that's associated with DOCSIS interface,
Right.
and keeping a very dense, very compact OLT in the head end. Right. So with Huawei's largest scale OLT, we can support 512 CMCs in the field.
Right.
Right. Each one of the CMCs can support up to 1K cable modems. So it's a very large scale solution. And that's suitable for most of the HFC networks today.
Interesting. So are there trials going on of DCCAP already, or any deployments?
Yes, we have very small deployment in the US already with a tier 3 operator. The initial use case for DCCAP in North America is actually in the rural HFC network, and uses a centralized OLT to aggregate all the DOCSIS subscribers back to a centralized location in the OLT.
Right.
And you can, by doing so, you can also offer centralized management, and something that has not been the case in the traditional cable operation.
Right.
DOS CMTS equipment has been very much a hands-on operation practices.
Right.
And with centralized OLT, there's a lot of remote provisioning and remote diagnostic capabilities. Really makes it much more cost-effective in terms of the OpEx.
So when should we look forward to seeing actual big deployments of DCCAP? Is it a 2016 thing, a 2017 thing?
I think with the January 2016 will be the GA release date for the DOCSIS 3.1 version of CMC,
Okay.
of the DCCAP. And I think at which point you will see many field trials around the world, including in the US. We are answering several RFP right now.
Right.
And I think the 2016 is really a launch point for DCCAP as a beginning of a mainstream cable access solution.
Okay, it should be a very interesting year coming up between
Yeah, I think so.
DCCAP and DOCSIS 3.1.
Yes. All right.
Thanks very much, Alan.
You're welcome.